Hey there, science fans! Today we're diving into the fascinating world of molar mass. You might be thinking, molar mass? Sounds complicated. But trust me, it's not as intimidating as it sounds. In fact, understanding molar mass is a superpower in chemistry. It's the key to unlocking a whole bunch of other important concepts. Think of it like this. In chemistry, we're dealing with tiny particles called atoms and molecules. They're so small that we can't see them with the naked eye. So how do we measure them? That's where molar mass comes in. It helps us relate the microscopic world of atoms and molecules to the macroscopic world that we can see and measure. Whether you're mixing chemicals in the lab or trying to understand the composition of matter, molar mass is your trusty sidekick. It's a fundamental concept that will pop up again and again throughout your chemistry journey. So buckle up and let's explore the ins and outs of molar mass together. Ready to unlock the secrets of chemistry? Let's go! Before we dive into the nitty-gritty of molar mass, let's make sure we're all speaking the same language. Just like every field has its own jargon, chemistry has some important terms we need to define. First up, we have average molar mass. Think of it like the average weight of all the atoms in a substance. It's the mass of 1 mole of a substance expressed in grams per mole, g/mol. Remember, a mole is just a fancy way of saying a really big number of something. It's like a dozen, but instead of 12, it's 6.022 times 10 to the 23rd power. That's a lot of atoms. We also need to talk about atomic mass. This is the mass of a single atom, usually expressed in atomic mass units, AMU. You can find the atomic mass of each element on the periodic table. Now that we've got our definitions straight, let's move on to the periodic table and see how we can use it to find atomic weight and average atomic weight. The periodic table is like a chemist's best friend. It's chock full of information about the elements, including their atomic weight and average atomic weight. But how do we find this information? First, let's talk about atomic weight. This is the weighted average of the atomic masses of all the naturally occurring isotopes of an element. Don't worry, we'll explain isotopes in more detail later. For now, just think of them as different versions of the same element. You can find the atomic weight of an element right on the periodic table, usually below the element symbol. Now, what about average atomic weight, AW? Well, it's essentially the same thing as atomic weight. It's just another way of saying the weighted average of the atomic masses of an element's isotopes. So, the next time you're looking at the periodic table, remember that it's not just a bunch of squares and numbers. It's a treasure trove of information about the elements, including their atomic weight and average atomic weight. From AMU to grams bridging the microscopic and macroscopic, we will delve into the fascinating world of chemistry, where the tiniest particles meet the tangible world we interact with daily. We've talked about atomic mass units, or AMU, and grams, but how do we convert between the two? This conversion is crucial for chemists and scientists who need to understand the relationships between atoms and the substances they form. It's like translating between two different languages. But don't worry, it's not as hard as it sounds. Once you grasp the basic concept, it becomes second nature, much like learning to ride a bike. The key to this conversion is a special number called Avogadro's number, which is 6.022 times 10 to the 23rd. This number is fundamental in chemistry and helps bridge the gap between the microscopic world of atoms and the macroscopic world we can see and touch. This number represents the number of atoms or molecules in 1 mole of a substance. A mole is a standard unit in chemistry that allows scientists to count particles by weighing them, making it easier to work with large quantities of tiny particles. To convert from AMU to grams, we can use the following relationship. 1 AMU equals 1.66 times 10 to the negative 24 grams. This tiny number reflects just how small atoms and molecules are. This means that 1 atomic mass unit is equal to 1.66 times 10 to the negative 24 grams. Understanding this relationship is essential for accurately measuring and working with chemical substances. So if we know the atomic mass of an element in AMU, we can easily convert it to grams by multiplying by this conversion factor. This process allows chemists to translate the atomic scale into a more manageable form. For example, the atomic mass of carbon is 12.011 AMU. Carbon is a fundamental element in organic chemistry and is the building block of life. To convert this to grams, we would multiply by the conversion factor, 12.011 AMU times 1.66 times 10 to the negative 24 grams per 1. AMU equals 1.99 times 10 to the negative 23 grams. This calculation shows how we can move from the atomic scale to a more tangible measurement. With practice, these conversions become intuitive, allowing you to focus on the more exciting aspects of chemistry, like discovering new compounds and understanding complex reactions. This journey from AMU to grams is just one example of how chemistry connects. It's a bridge built on the principles of conversion and understanding, making the invisible visible and the complex comprehensible. Scientific inquiry and the beauty of understanding the universe at all scales. Keep exploring, keep questioning, and keep bridging the gaps. The world of chemistry is vast and full of wonders, waiting for you to uncover its secrets. Happy converting. The mole, a chemist's best friend. Here, we will delve into one of the most fundamental concepts in chemistry, the mole. But first, are you enjoying the video so far? Subscribe so that you ace that chemistry class. Now that that's out of the way, let's get back to the video. Remember Avogadro's number? It's a number so large that it can be hard to wrap your head around. Avogadro's number is a fundamental constant in chemistry, and it's all thanks to the concept of the mole, which, fun fact, this number is named after the Italian scientist Amedeo Avogadro, who first proposed that equal volumes of gases at the same temperature and pressure contain an equal number of molecules. But that's besides the point. The mole is simply a unit of measurement that chemists use to count atoms, molecules, or other tiny particles. Just as a dozen represents 12 items, a mole represents 6.022 times 10 to the power of 23 of something, such as atoms, molecules, ions, electrons, depending on the context. That's a huge number. To put it in perspective, 1 mole of marbles would cover the entire Earth to a depth of about 3 miles. Why do we use moles? The answer lies in the incredibly small size of atoms and molecules, because atoms and molecules are so small that it's impossible to count them individually. Even a tiny sample of a substance contains an astronomically large number of these particles. The mole gives us a way to talk about large quantities of these tiny particles in a more convenient way. Instead of dealing with unwieldy numbers, we can use the mole to simplify our calculations and discussions. And here's where it gets interesting. 1 mole of any substance has a mass equal to its molar mass in grams. This means that the molar mass of a substance, which you can find on the periodic table, tells you how much 1 mole of that substance weighs. That means if we know the molar mass of a substance, we can easily convert between mass, moles, and number of particles. For example, if you have 18 grams of water, you have 1 mole of water molecules, because the molar mass of water is 18 grams per mole. The mole might seem like a strange concept at first, but it's a crucial tool for chemists. It allows them to work with the quantities of substances that are practical for laboratory experiments and industrial processes. It allows us to bridge the gap between the microscopic world of atoms and molecules and the macroscopic world that we can see and measure. By using the mole, chemists can translate the invisible actions of atoms and molecules into measurable, observable quantities. So, the next time you hear about moles in a chemistry context, remember that they are not just a number, but a powerful tool that helps chemists understand and manipulate the building blocks of matter. The mole truly is a chemist's best friend, and that's why the mole is so important. It simplifies the complex world of chemistry, making it easier for scientists to communicate their findings and advance our understanding of the natural world. Molar mass, GAW, from atoms to grams. Here, we will delve deeper into the concept of molar mass and how it connects the microscopic world of atoms to the macroscopic world we interact with daily. Now that we're familiar with the mole, let's talk about how to determine the molar mass of an element. The mole is a fundamental unit in chemistry that allows us to count atoms and molecules in a manageable way. Remember, molar mass is simply the mass of 1 mole of a substance, expressed in grams per mole. This concept is crucial because it bridges the gap between the atomic scale and the scale we can measure in the lab. For elements, the molar mass is numerically equal to the atomic mass. This means that the atomic mass you see on the periodic table is directly used to find the molar mass. For example, the atomic mass of carbon is 12.011 AMU, so its molar mass is 12.011 grams per mole. This direct relationship simplifies many calculations in chemistry. Another name for molar mass is gram atomic weight, or GAW. This term is often used interchangeably in textbooks and scientific literature. It's just another way of saying the same thing. Understanding this terminology is important for grasping the broader concepts in chemistry. So if you know the atomic mass of an element, you automatically know its molar mass, or GAW. This makes the periodic table an invaluable tool for chemists. For example, let's say we want to find the molar mass of gold, symbol AU. Gold is a fascinating element with a rich history and significant industrial applications. We can look up the atomic mass of gold on the periodic table, which is 196.97 AMU. This value is crucial for various calculations in both academic and industrial chemistry. Therefore, the molar mass of gold is 196.97 grams per mole. This information helps us understand how much 1 mole of gold weighs, which is essential for practical applications. See, determining molar mass is as easy as looking at the periodic table. With this knowledge, you can now calculate the molar mass of any element, making your journey through chemistry much smoother and more intuitive. Real-world applications of molar mass. We've explored the concept of molar mass and its calculations. Let's see how this knowledge is applied in real-world scenarios. Understanding molar mass isn't just an academic exercise. It's a tool that chemists use daily to solve practical problems and innovate in various fields. Imagine you're a pharmacist tasked with creating a new medication. You need to mix precise amounts of various chemical compounds to ensure the drug is effective and safe. Here, molar mass becomes your guiding star. By knowing the molar mass of each compound, you can accurately measure out the amounts needed to achieve the desired chemical reaction, ensuring the right dosage for patients. Or consider an environmental scientist analyzing pollutants in a water sample. They use molar mass to convert between the mass of contaminants and the number of molecules present. This allows them to assess the potential impact on ecosystems and propose effective remediation strategies. Even in the food industry, molar mass plays a crucial role. Food chemists must understand the molar mass of ingredients to ensure that products are safe to consume and meet regulatory standards. This knowledge helps in formulating everything from nutritional supplements to everyday snacks. In the field of materials science, researchers use molar mass to develop new materials with specific properties. Whether it's creating stronger alloys for construction or more efficient batteries for electronics, understanding the molar mass of the elements involved is key to innovation. As you can see, the concept of molar mass extends far beyond the classroom. It's a fundamental principle that underpins much of the work in various scientific disciplines. By mastering this concept, you're not just learning chemistry, you're gaining a valuable tool that can be applied to solve real-world problems. In conclusion, mastering the concept of average molar mass is crucial for any chemistry student. It bridges the gap between the microscopic world of atoms and the macroscopic world we interact with daily. By understanding this concept, you can better appreciate the intricate details of chemical reactions and the properties of substances. Keep practicing, and you'll find that this fundamental concept will become second nature. Thank you for watching. Like and subscribe if you enjoyed, and happy studying. Be sure to have a nice night and good night.